Hello and welcome back. Last week we had a clear night, and as I was looking at Sky Safari trying to decide what to image that night, I noticed that there was a comet, Comet 2017 T2 PANSTARRS, that was going to be moving right by the double cluster, and I thought I should try to image that. Didn't matter that I didn't really know what I was doing. I had seen a presentation last year that one of our club members had done, and I didn't really remember it, but I had enough of an idea that I felt safe trying to proceed. After all, what could go wrong? Well, pretty much everything. So I only got about 2 hours and 40 minutes before the object started to go behind a tree. And so I had 30 minutes of red, 30 minutes of green, 30 minutes of blue, and then again red, green, and blue, until about 10 minutes into that last blue, the filter, or the tree came up and started to obstruct the view. So I did a normal integration, aligning on the stars, and I got pretty much what you would expect. Here's the double cluster, and down here in the bottom left quadrant is the comet. And there it is. In fact, we have two comets. And that's not unusual because in this red frame, of course, we have an hour difference in time between the two sets of red frames. And so while the comet doesn't line up in any one frame, there's a fairly big gap between the two sets of red. And that's true for all the others as well. If you actually combine all of this, it kind of makes an interesting comet. We get an alternating green, red, blue comet. And actually, I guess that's blue, green, red. Although kind of cool looking, that's not really what we were after. So what I wanted to do, what I had in mind before I started all of this, let's go ahead and close all this down. Was to use the comet alignment process. And what comet alignment does is it allows me to add in all of those frames that we got. And register them based on the comet. So it'll take just a second to put all of these in here. And then we need to set an output directory, which I will just call Comet Aligned. And let's actually get rid of all of that stuff that's in there from before. Okay, comet aligned. Now the next thing we have to do is to set the location, to identify the location of the nucleus of the comet in the first and last frames. Thankfully, comet alignment is kind enough to look at the tag in the FITS header for when the exposure was created, and identify the oldest and youngest frame. And so we just need to come down here and click on that frame. And you can see it's marked here in the frame where that is. And then we do the same in the last frame, and this is one where the tree was coming in. You can see it there coming in from the left. And for this first one, we can ignore the operand image and we just can apply this. This will take a little bit of time to run, and so I'll show you what we get when that finishes. Now what'll happen is we'll get all of those images aligned on the comet written into the comet aligned subdirectory, and then I will just integrate the red, green, and blue frames normally. The goal with this is that once aligned on the comet, the stars should move from frame to frame, and when integrated, all of the stars, or at least almost all of the stars, should disappear. So we'll come back when this finishes and see what we get. The comet alignment process is finished, and I've run the first integration on the red frames. And I used Windsorized sigma clipping as my rejection algorithm and dropped sigma low down to 1 and sigma high down to 0.5 in the hopes of being able to reject as much as I could to make those stars go away. And indeed, if we look at our rejection here, it seems like we rejected quite a bit on the high side and on the low side. But when we look at our image, not so much. If we come down here and look, the comet looks great. But we have two sets of star images, of course, one from the first set of red frames and the other from the second set of red frames. And so that has way more stuff in the background than I was hoping. So let's proceed and see. Well, I'll integrate the green and the blue frames, and then we'll come back and see what we got. Our 3 integrations have finished, and you can see they all look pretty much the same, which is to be expected. Let's put them together and see what we get. And it's pretty much a mess like you'd expect. The comet doesn't look too bad. But if we zoom in and look at it, it's almost like it's going at warp speed. I don't think this is usable, but we'll continue on and see. So for the next step, we need to subtract this comet from all of the individual star-lined frames. And we'll go back to the comet alignment process for that. So what I've seen recommended is to extract a luminance of this, and we'll save that. We'll save it here in the process directory. Now we come back to comet alignment. I don't know why it changes size on me like that. And this time we'll save our frames into this star-aligned directory. for parameters, we've got the same original frames that were created by star alignment. And we've already identified that, so we don't need to do that again. But this time under subtract, we want to take that comet-aligned luminance image and put it in there. That was created by image integration. And the operand is comet-aligned. We want to subtract that from each of these images and put the results in that directory. So again, this will take a little while to run. And when it finishes, then we get to integrate the red, green, and blue results from that. And that should give us, in theory, a star field without the comet. So we'll see what happens when this finishes. The comet alignment process is finished, in theory, subtracting the comet from each image. I've taken the red filtered frames from there and loaded them here into image integration. And we'll try to integrate those. And let's change this again to Windsorized. I don't know whether we need to be quite so harsh on the integration as we were last time, but let's try lowering it some and see what we get. So I'll see you again when this integration finishes. Okay, our red frames have finished. We don't need the comet alignment process anymore. We can see we've still rejected quite a bit of stuff on the high side and a fair amount of stuff on the low side. But what about the all-important integration itself? And that does not appear to have worked. In fact, it's kind of a mess. Well, that's not a great sign. Probably, from the looks of things, used too low of a sigma clipping threshold based on the kinds of artifacts we're getting. So what I'm going to do is reintegrate this with normal settings, and then I'll do the other two, and we'll put them together and see what we've got. But it's not looking good. Our 3 stars sans comet integrations have finished, and of course all 3 of them still do appear to have the comet. But let's integrate those and see what we get. And indeed, we still have a comet. So I think that these artifacts we're seeing here aren't from the sigma clipping. They're from the bits of stars that were left in the comet-aligned pictures, and they're causing all sorts of problems here. So that's definitely a problem. Now, in theory, what we're supposed to be able to do at this point is take this picture and use pixel math to combine it with that picture. So let's call that comet. Let's call that stars. So what I've seen recommended is to take something like 2 times the comet and add it to the stars. And that should be okay. And there's what we get. We're supposed to rescale that. So let's back that off again. And of course, that is pretty much terrible. So why are we getting such a bad result? I know the answer to part of that. The comet, as it turns out, is, or at least at the time that these photos were taken, was 1.6 AU from the sun. So the comet's moving relatively slowly from frame to frame, and there was no delay between frames. So there's not much change from frame to frame. There's just enough of a difference that the comet doesn't line up if you do a normal integration, but there's not enough of a change that the stars don't almost line up when we do the comet-aligned integration, and so we end up with this mess. We can test this theory by doing an integration on just a subset of our comet-aligned frames. So just to do something quick, let's take our first and last frames from red from each of the two sets. So that would give us a frame at time 1, time 30, time 90, and time 120. Those are the 4 frames that are as separated in time as we can get. And in theory, that should have fewer artifacts. So we'll take this red frame, that red frame, that red frame, and that red frame, and we'll do percentile clipping. Don't actually have ever used percentile clipping, so I'm not sure what those values are telling me here, so we'll just go with the defaults. Okay, you can see we have lots of high rejection, which is encouraging. Fair amount of low rejection. And a much cleaner, but still not clean, star-only rejection. I can sort of see why we still have stuff up here, because there's so many stars in the double cluster that, if you have star A and star B, that by the time we've moved, A may be where B was, and so you don't get the rejection that you wanted. But for some of these others, I'm not really sure. I guess they're just the big stars maybe were just so big, pixel-wise, that we just didn't get enough movement in half an hour to make them reject. So that's kind of discouraging. I couldn't get the image that I wanted. So what can we do? One of the things that I've seen done is to use Blink to produce a video. And if we load all of our original registered frames into Blink. Now to do this properly, well, let's just do it with our calibrated frames, since they're all in one directory. And this way they will go in chronological order. So if we load these all into Blink, and sorry, this will take a few seconds. There's about 162 frames, I think. All right, the frames have loaded into Blink, but we want them to apply an automatic STF to all images, not just to the first, and then use that first STF, which is the default behavior. So let's go ahead and click that, and unfortunately sit through that whole process again, although fortunately it's not quite as bad. Now we can, do our normal blink thing here. Now ideally you should do this with the registered frames, not just the calibrated frames like I'm doing here. But when you do that, copy all of the red, green, if you're using a mono camera like I am, copy all those red, green, and blue frames into one directory so that your file names will sort properly together, and then you can load them all in at once. If you load them in all the reds, all the greens, all the blues, then your frames aren't going to be in order in Blink, and when you make a video, it's not going to work. So once you're here, you can click on this button here to make a video, and you need to have this program FFmpeg, which you can get from here, ffmpeg.zerono.com. I'll put a link to that in the notes so you can find it. FFmpeg is a freeware piece of software, and it's used to do video manipulation. And in this case, Pixinsight is going to use it to construct a video from the series of frames. Depending on what you want to do with that video, this in and of itself may be sufficient. And so all you have to do is hit run, and it will go and do that. When you do that, you will get this. You'll get all of these PNG files, which are the individual frames rendered as PNG files, and then you'll get an AVI file, which is the video. And here we go. So that's one way to make an animation. Now, in my case, I wasn't crazy about that animation, so I decided to bring it into Final Cut Pro and actually do a little more editing on it. And I'll show you the results here next. What you're going to see is the not quite full frame. I'm going to crop it a little bit. That shows you where the comet is. And then after that runs, which only takes about 7 seconds, I will zoom in on where the comet is so you can actually see the movement a little better. This is about all I've been able to salvage from this set of frames. It's definitely been a learning experience. The next time I do this, I think I'm going to do two things. One is I'm going to use my one-shot color camera, and two is I'm going to take a look at how much movement I should expect from the comet, and then leave a delay between exposures to ensure that there's enough of a gap from exposure to exposure to be able to do this comet alignment process properly. The other option is to guide on the comet and just let the stars trail, which is kind of what we get when we just do that comet alignment integration is what we almost end up with in my case. I'd have probably been better off, given how little comet movement there was, to just do it that way and let the stars trail. And that's probably better done with a one-shot color than with color filters. So I'll show you this video and hope you enjoy it. And if anybody has any ideas on how I might actually salvage these frames for doing the picture with the clear stars and the clear comet, please let me know.